Welcome to my Module 2. I'm Adam Shelp, and I'll be predicting the percent likelihood of traveling to space and extraterrestrial plant growth. Before we start, we need to know what moderation is and how it is calculated. The first step of any regression model is to conduct your basic regression analysis, the relationship of which you can see represented by C. The second step calculates how the moderator interacts with the relationship between X and Y, as well as with the dependent variable alone. The full moderation equation can be seen detailed below. Our first study focused on predicting one's likelihood of going into space, a continuous variable, with athleticism, also continuous and rated on a Likert scale from -2 to 2 as the dependent variable, and happiness rated on a Likert scale from 1 to 4, where 1 and 2 are unhappy and 3 and 4 are happy, as the moderator. After running a basic analysis on the data, we first looked at the correlations between variables, highlighted here in pink. As we can see by the relationship between x1 and x2, our moderator, there seems to be low multicollinearity between our predictors, which was further confirmed by a low variance inflation factor. Beneath that, we can see how our variables correlate with the independent variable, indicating how well one predicts another. In this case, athleticism has a strong relationship with likelihood of space travel, but happiness and the interaction only show a moderate relationship. To the right, you can see how the data look in a scatter plot. We are going to mean center our data, however, to boost interpretability and pass the diagnostics. After centering the data, we use significance levels to predict the shape of the plot. So in this case, all our estimates are significant, which aligns with number 16 of the truth table from class. Here is a clearer prediction with labels from the equations placed on the graph for clarity. Moving to our actual data, which passed diagnostics, I have highlighted the estimates provided by our analysis, which were then placed on the plot in the respective places with the respective formulas placed in the bottom right corner. As you can see, our current data do not look exactly as we had pictured initially, but had we taken into account the negative B3 or the difference between the slopes, we would have created a more accurate prediction. In terms of our story, our findings suggest that athleticism significantly predicts one's likelihood of going into space, but this is moderated by respondent happiness. Happy participants are just a little less likely to travel to space as their athleticism increases, while unhappy participants are slightly more likely. In our second model, we are looking at how sex and the time you can hold your breath affect your likelihood of traveling to space. Again, we started with our uncentered data to see the relationships between our variables, this time highlighted in blue. From this, we can reasonably say that there is low multicollinearity, again supported by a VIF calculation, and a moderate to moderate strong relationship between likelihood for space travel and our other variables. Again, you can see our significance levels and which model output they predict, and the expected model. Now that we've seen how we expect the model to look, let's look at our actual centered data. As before, the plot is labeled, but this time our data look exactly as expected. From this, we can conclude that the longer you can hold your breath, the more likely you are to go to space. Also, while women appear to be somewhat more likely to go to space than men, sex does not moderate the relationship between breath holding and travel likelihood. Moving into our final moderation model, we will be looking at how your age and pineapple pizza preference predict your likelihood of space travel. As you can see by our correlation chart, there is low multicollinearity between our predictor variables, but unfortunately weak relationships with likelihood for space travel. Uncentered data, which pass the Gauss-Markov assumptions, are pictured here. Based on our significance levels, highlighted in purple, we expect to see a similar plot to number 10, pictured here. Finally, our centered data. As you can see, our actual model pretty nicely matches our predicted model and suggests that the older you are, the more likely you are to travel to space. This is moderated, however, by whether you like pineapple on your pizza, such that those who dislike it are more likely to space travel when young, and those who like it are more likely to travel the older they get. Pretty good to know for any hopeful astronauts. Changing gears, we are going to be looking at some mediation effects next, so you can see a representation of the full model here. When conducting the analysis, however, there are 3 steps one must follow. According to Barron and Kenny, the first step is to calculate C, or the unmediated relationship between X and Y. As before, this is your typical linear regression. Step 2 introduces the mediator, but only calculates its relationship with X. The third and final step calculates the relationship between x and y once any variation is claimed by the mediator. This is different from a moderation model because the new variable offers an indirect effect, which often affects the strength of the original prediction between x and y by siphoning some of the prediction. In our first mediation model, we are going to look at how well plants will grow once you've made it to space, as predicted by nutrient levels and the strength of gravity acting on the plant. Pictured here are those relationships between our variables, which we will interpret in the order suggested by Barron and Kenny. To start, we look at C, or how extraterrestrial plant growth is affected by the amount of nutrients before we add the mediator of gravity. As you can see by the highlighted p-value, C is significant. There is no type 1 error, and we can continue our tests. Next, we look at A, or the relationship between amount of nutrients and strength of gravity. Again, our estimate is significant. Barron and Kenny suggest that if this is not the case, then the mediator may not even be associated with Y. However, that is not a problem we currently have, so we can move on to the third test. Finally, we look at B and C prime, or the relationships with X and the mediator with our outcome variable. According to the highlight, both paths are significant, so Preacher and Hayes suggest that we will ultimately fail to rule out mediation, but we'll have to conduct bootstrapping and Sobel tests to confirm. In this case, though, the model suggests that while amount of nutrients predicts plant growth in space, the partial mediation of gravity strength weakens the original relationship. Finally, we conducted a bootstrapping test to determine the probability that our data would be observed given the hypothesis. According to davidakenny.net, bootstrapping is when you conduct random sample with replacement tests to get an estimated indirect effect, which is A times B, for the model. A bootstrapping model is run because it is less conservative than the Sobel test, which has been very popular in recent science, but results in much lower statistical power. The standard error bars are reflections of normality, and both the bootstrap and Sobel estimates should be close to each other in the plot. As this is the case, and 0 is not between our standard errors, we can officially fail to rule out partial mediation. Moving to our second mediation model, we will be looking at how the amount of water given to a plant mediates the relationship between the amount of soil and extraterrestrial plant growth. Here are our variable relationships once more, starting with C, or how plant growth is affected by the amount of soil per plant before amount of water is introduced. As indicated by the highlighted p-value, C is significant, so we can continue our test. Next, we continue to A, or the relationship between amount of soil and amount of water. Our estimate is significant, so again, we will move on to our third and final regression. Finally, we look at B and C prime, or the relationships with soil and water with plant growth. According to the highlighted portion, only the mediator, or B, is significant, suggesting that the relationship between soil and plant growth is entirely mediated by water amount, which is what we would expect to see on previous research. To test this, we once again conduct a bootstrapping analysis, in which 0 is outside our standard errors and the mean and estimate are overlapping, meaning we can officially fail to rule out the full mediation. Thank you for your time.